Hey, thanks for joining me in this tutorial, and today we will be looking how to use many-to-many mapping and create a three-dimensional grid of points which we will then map to the origins of cubes. And we will start by creating a grid in three-dimensional space. So let's draw a grid mesh, and now let's create one vector, right? So this will be the base component that will do all the hard lifting. So here you see that we now have a single point in the middle of our coordinate system. And if I preview the data of this component, you will see that it's just an array with three numbers, right? So 0, 0, 0. And if I change it here, it will change here as well. That's quite simple, right? But how can we create multiple vectors? And how can we create grids of vectors? Well, we will be using a span component. You could also use range, but that's more limited. So span component is a nice one because it takes the minimum value, the maximum value, and it also takes the step, and then it produces a list of numbers. So let's look into that. Let's make a span that has a step of 1, it has starting minimum value of 0, and the maximum 10. Let's copy this preview component and let's check how this output looks like. Okay, so we start with 0, right? And we end at 10. And we have here 11 numbers, right? Because, yeah, we have 0 as well here. So this is really nice. But if we try to plug this now into the y coordinate, you will see that it doesn't work. And it doesn't work because the y coordinate expects us to give it a number, but the type of the output of the span is the list of numbers. And you see in this preview component that the number array is nested here. And what we want to do is flatten the output of the span component in order to be able to pass it along to the y direction. So let's do that. Let's flatten it. Let's give it here. And let's provide it to the y axis. And now you see that we've produced 11 points, right? Okay, if we watch what the flatten component did, so you'll see that we reduced the array levels by 1, and then the vector component was able to just iterate through those points and generate multiple vectors that are now sitting in this output. This is really exciting because we did not need to write any for loops or anything. What we will do, we will use the same trick to create a span for x direction, and let's plug the flatten output here. So now you see that we've created a two-dimensional grid in space that is going from 0 towards 10, but let's maybe make it a little bit more interesting. Let's go and center everything. So let's go from -5 to 5, from -3 to 3, for example, and you'll see that now everything sits nicely on the coordinate center. And also let's create the z direction span. And that one, let's make to go from 10, -10 to 10. And let's flatten that as well and plug it in the z direction. So now we have quite a lot of points in 3D space. And it's now a three-dimensional grid of vectors. They're all outputted here from this component, and we can pick them up when we will be creating a cube. So let's create the cube. Let's pick this one from OpenCascade technology kernel. Let's make it a little bit smaller, so 0.5. And now if we will try to plug these in, you will see that cubes are now just created on all of these center points. And if you will be checking the scene, you may notice that the frame rate dropped a little, and that's because we created quite a lot of geometry here, and that is not really optimized. So let's hide those vectors for now, and let's hide those cubes. What we actually can do to improve the performance is to make a compound shape out of these cubes. So let's try to plug the output of the cube to the make compound component, and you may already know that this won't work, right? And it doesn't work because this component expects us to provide it a list of shapes, and this component has the output which indicates that it provides us with a single cube. So this might be a little bit confusing to you, because if you preview this data, you'll see that it sort of sits in one level of the array, and you may think that this is sort of a list, but the list is only when it's nested in deeper level. So that's what we will be doing. We will create additional level for this list. So now what we will do is we will create a list, and let's preview that data. So let's compare it one by one here. So you see now that all of these shapes sit in sort of second level of the array, and that is then, you know, understood as a single list that can be passed into a component that expects a list. So this is a little bit tricky to get right, but yeah, it works. And now we have optimized the rendering of these cubes, and now it's a single mesh that we've produced, which renders really fast in BabylonJS game engine. Okay guys, so what we managed to do in this short tutorial is we used many-to-many mapping, right? Because we were able to produce a big amount of vectors without writing any for loops. And yeah, we did not use this one-to-one mapping, which I discussed in different tutorial. If we would use that, you would see a very different result here, right? So this is what one-to-one mapping produces, but we used many-to-many mapping, which sort of created all the possibilities of all the vectors for all of these coordinates that we pass to the vector component. I hope you enjoyed this tutorial, and let's see each other in the next ones. Cheers!